Hello everyone. Hi. Hello people. Welcome. I'm just setting stuff up. The time has come to make logging great. I don't know, for the first time. Yeah, so probably I'm gonna create it as a separate module. Just like this. Yeah, and this is kind of what we're going to do today. This is my doodle from yesterday, where the idea was that we will have a separate, not separate, single shared data structure or single contiguous piece of memory that will be subdivided to some amount per each thread. And each of these parts will be like a mini ring buffer that will wrap around when it's out of place. And then there will be a single unified logger, which we'll call in logger, that will consume log entries and then process them further. Yo, Predict, hello, thank you for the black fun. Appreciate it. Yeah, this is a piece of art, I know. I know. Yeah. So I actually never done something like that before, like this before. And admittedly, I know everybody will disown me. I never wrote like a multi-threaded lockless code before. The only multi-threaded code I ever written was, was with using some kind of locks. So yeah, that would be the first one. And I've never implemented my own ring buffers. So yeah, this is gonna be a lot of probably a lot of bad code will be today. So I guess I will start with the data structure. So what's gonna be called cluster ring buffer, I guess. What would it even have? I mean, it will certainly have, I guess, num clusters. I guess it's gonna have a memory, which is something like this. Should it be typed or not? I don't know, because in my idea I probably want to just log. So for now, log accepts strings, right? So it accepts kind of strings and the log level, whether it's debug or not, debug, error warning, and stuff like that. And I was thinking that I maybe want to make logging slightly more structured, for the reasons that, sometimes I don't want to allocate strings within my hot loops, and maybe I could just parse like a struct with an error info, and then the logger thread itself will, you know, format the string, like use whatever allocator it wants for string without doing any allocations in an actual input thread. That's my kind of idea. I want to make my input handling code as unencumbered as I can to the best of my ability. Excuse me. I have a little bit of a sore throat. I don't even know why. Maybe because it's the fall has finally come to Serbia, so the air maybe is a little bit drier than normal, and I'm kind of sensitive to dry air. So I'll try to not like crash out that much today. So num clusters. Then memory, should it be like unified? Should probably be unified. And then each cluster, right? If we look at it, each cluster should have like its own sort of position into its chunk, right? For one thread, this is gonna be kind of like this. Yeah, so it's like, it's kind of like right header. So yeah, so header, right positions, which is, it's gonna be like array of, like of these. We could kind of make it polymorph, right? And then we could use it here. So this means that the amount of clusters would have to be known at compile time, which I think in my case it's true. They will be known at compile time. And I won't even have to, yeah, in my case it will definitely be known at compile time. And num clusters, I guess this is gonna be a constant as well. I actually don't think it's gonna compile, will it? Oh, it's because I'm not using it. Let's import it. And I was gonna fail, yeah. Cannot use, so yeah, this is like, right positions. So position is an integer. Use as 64 everywhere. No, look at this, it's actually fine. And set logging and config file paths, and then init logging. So here we could like initialize stuff. And for example, we could do something like buffer equals to like clustered ring buffer. And now it doesn't work. Attempt to use polymorphic struct, yeah, because we need, and how many threads we have? We have main, then we have input handling, yeah, main, input handling, window detection, I think that's it. Right. We can actually see here. So we have 1, 2, 3, also timer thread. And plus main is gonna be 4. So we excluding logging thread because logging thread will be consuming the stuff and it won't actually write anything there. Logging thread will use login thread will use like std out if something errors out there. Or it might also write to UI to the window, because I kind of have ideas of how to integrate logging into my own UI, so that my dear users don't even have to look at the file most of the time, assuming they have UI showing up at all. So yeah. So and now this, yeah. So yeah. As I expected, you can't do this in Jai because you can't, unlike in C. Unlike in C, you can't refer to an identifier within itself, because in C, if you have like a function named foo, right? So like blah blah blah, you can then create a variable named foo. So you can do something like foo equals like foo, right? You can do this in C, but in Java you can't do that. So you have to actually call this with different names. It's gonna be num clusters and this is gonna be clusters. Actually, should I even store it? I can probably not store it like at all. Right, and just refer to... it's actually fine. Because it's gonna go to a constant storage, so I'm not gonna have to pay a runtime cost of storing it in a struct. Not that it matters anyway. Fuck is this music? Yeah, there you go. What else do I need? Do I need to store read positions? Because I will have one reader for all of them. Probably should. Yeah, probably should. And I guess that's it. I guess I can do like... I guess I can do allocator. Yeah, I guess I can do allocator as well. So we can start. We can start like that. And we also need to store size, like star size per cluster, like cluster size or something. Maybe not. So init ring buffer is gonna accept a pointer to this thing. Or not, maybe not even. Let's check how other procedures, like how other data structures use allocator in Jai. So we have, let's check maybe bucket array. Yeah, this is a good one. So it like has an allocator on it. And do we have like an init or something on it? Uh-huh. Yeah, so you kind of have to store it yourself. Let's just check how it's used. I guess it just sets it from the context when you create it. And probably yeah, I guess that's what we do. I'm not gonna decide it if I want to make it typed or not, or just store memory as bytes. I'm not gonna bother with init in it. I'll just do it all in line for now. So num clusters, size per cluster. Hey tool, is bucket array just a hash map? No, it is an array of buckets. That's literally what it is. Yeah, so it's an array of buckets. And bucket is just, right, some array with items. So it, hey, hello, it doesn't have any hash functions. So when you want to find something, right, you, wait, there was an operator overloading, yeah, there you go. So let's say you want to get an index, right? So you do some math to get an index of a bucket. Then you get the slot in the bucket. Then you get like bucket index from bucket, and then you get from the slot. So this is how you get stuff from the array. Yeah, it's a very common data structure. So there is no hash functions, nothing like that. And I think one of the advantages is that it preserves like pointers. I think. Like it doesn't reallocate stuff. Except you were hashing. Yeah, I see. Yeah. So size per cluster, I don't know. Let's do 32. So memory, I guess we just keep it untyped for now. Well, if we keep it untyped, how do we then know what to cast it to when we consume it? We can store it as any, right? So it could be like, it could be array of any's. Which is kind of bad because this is an indirection, and so I don't want any indirections here. I want just contiguous storage where you just put stuff there, so that threads that log, so that any thread that logs shit there doesn't have to how do you say that, own any memory. Yes, this is it. So I need to like warm up a little bit. So yeah, so I don't want it to be an array of any. I guess we can just do array of bytes. Right. Yeah. Seems like that's what we need, right? Size per cluster and should I make it constant as well? I mean, why not? And then this actually can also be custom, right? Non-constant, an instance of it. I can make it a default. So if it's not constant, then I don't need to make the struct polymorphic. I can remove this, just make this typed, and then create it. Right. Yeah. And this means I can also allocate this shit on the stack, which is probably like a bad idea. Actually, you know what? I don't think I want to make them constant. I can, but I don't think I want. Yeah. Let's not do it for now. So this is gonna be clusters like S32 or like U32, whatever. Cluster size, also like items, U8, write, read positions, and allocator. Something like this. And then in my main, yo Phoenix, hello. Anything in the struct parameters is going to always be constant. Well, not necessarily. It's not necessarily going to be constant. So consider this just another type of procedures. So you can do it like this, and then like num clusters s32, and then like size like s32, right? And in this case, it's not gonna work because wait, well, let's say I just put the 2 here. Like it's gonna compile, right? But if I, for example, put num clusters here, oh, it still compiles. That's actually weird. So yeah, I guess struct constructor assumes these to be constant. But what if I do? Yeah. Loss of, wait, what? Loss of information. The fuck? Does it just work? Yeah, look at this. This is what I was trying to this is what I was trying to trigger. It basically tells you that you can imagine all struct parameters have an implicit dollar before their names. So I was typing dollars explicitly, but you don't technically need them. Yeah. Hey Sush, hello, welcome. It's going well. I'm just like trying to come up with stuff. Constructor. It's not really a constructor. Oh, excuse me. That's fine. Right, so we do buffer buffer like clusters. In our case, it's gonna be 4. And then buffer cluster size is gonna be, how much do we want per cluster? This is like in bytes, right? And items, this is like just data. This is kind of like raw data. We could do like 4K, maybe like like 4K, right, per cluster. They can't have, yes, they can't have runtime version. I don't think it breaks it. I think it just, because I did it right before you joined the stream, I did it with dollars, it didn't break. So I think if it sees dollars, it just doesn't complain, but if it doesn't see dollars, it just like assume dollars. Because I mean, that's what it is, right? It's like higher order struct. I don't think you can do double dollars. I don't think optional bakes are supported. Let's try it out, I actually don't know. And then... yeah, I think $$ should break it. Right, so if I do 1 here... yeah, cannot use on a declaration that has no identity. Oh! No. This is the wrong error. Let's do 64. This is... oh, right position. It compiles, look at that. So I guess in this case it worked because this is a constant, and if I provide A, now it breaks, yeah. It breaks. No, it compiles because I provided a constant there. So as soon as I don't provide a constant, it will break. So it still tries to kind of do its best. In terms of, yeah, so it parses. It parses, but as soon as you break the constant rule, it kind of craps itself. Yo, Leonte, hello. Welcome to the stream. Yeah, dollar, dollar, dollar. I would like some dollars now. Yeah, it is lenient. Lenient is definitely the right word for it. Okay. So clusters, cluster size, right positions. So I guess this would have to be chat overlay stole one of the dollars? What the fuck? Wait. How's that possible? Oh, it did! Holy shit. How did even...
Found some dollar.
Oh, thank you Phoenix for 100 bitcoins. That's weird that Streamlabs chat just does it. I wonder if it's some, you know, if it is some like escape. If it tries to do some like string escapes on that and just craps. What if you try some like XSS injection and see how it reacts? Yeah, look at that, it stole 2. Yeah, 100 bitcoins. Anything over 2 gets nuked. Backslash gets inserted verbatim. Also, yeah, I meant to fix the Streamlabs like overlay thingy where it tries to treat nickname like as a column, so it occupies way more space than it needs. It means I will have to write custom CSS though. Yikes. I mean, it is what it is, right? So yeah, buffer size, clusters, and then like read and write positions. Wow. I guess this will have to be allocated to. So how does it work? So maybe we do provide one of them. I just don't want to manage these like separately. So we can do num clusters and then have these as a, I can have that and then right, I can have this. But these can be managed at runtime and should still work, yeah. And then I can just allocate buffer data equals alloc. And how do you use alloc? There you go, just size. And alloc is gonna be right. Now I can do this, and alloc is gonna be num clusters times right. Kind of like this, yeah. And buffer count is gonna be I guess this. I should technically align it. Do like power to align. Does it do it by default? I don't think it does. Was there a helper for it? There definitely was. Because I'm a web monkey, I don't remember how to align it myself. It's something like something minus something. Or you can do this, right? Which I think only works on like to complement something. I don't know. I'm stupid. Align forward, yeah, there you go. That's what I was looking for, and it's also in basic. So original size, alignment, and what does it do? So that's original size plus a alignment minus 1 divided by alignment and then times alignment again. So yeah, and it means you get remainder of original size modulo alignment. Ooh. And then if remainder, you just you just add this remainder. Okay, yeah, this is actually much more understandable. Yeah. And yeah, and plus tilde, I think it only works on when you align by the power of 2, right? Which obviously we do. Yeah, hey Mzoko. I don't know if I said hi. I might have said hi and then instantly forgot about it. This is what streamers usually do. Only works on PO2s. Yeah. And the way you use it. Oh, nice one. What's this? Ah, this is for new array. Yeah. So I think you just provide 2 over there. So you would do something like original size so that it becomes an even multiple of alignment. Yeah. So you do a log forward bytes like 2. I think this is what you do. But count, I guess, can still use bytes. Right. I mean, I guess it's fine. So now we allocated the scrub, and now I need to like, let's print. Print. Bytes is gonna be buffer that data count. Count is not a, it's buffer that data that count. And I need to run it as well. There you go. So 16,384. 16K. Yeah. And this kind of initializes the buffer. And now what I need to do is I need some kind of a helper functions that when you call log, it would write into a separate segment of this buffer. And not only write, it should also like wrap around. Something like this. Right. So let's think about it. There will be like log. That will accept the same thing that regular log accepts. Like basic does. And log in basic accepts, oh wait. There you go. So format string, arguments, color location, some flags, some user flags, and then log section. This crap gets added onto some special info. The fuck is log source identifier? Huh? I've never seen this used before. Arbitrary identifier. Actually, you know what? Let's read about logging first. How does it like work and stuff? The context-based structure in modules preload helps programs and modules to coordinate. Yeah, one of those tasks is logging. Preload defines the following procedure type, logger. If you make a logger, you can set context logger to be that new routine. And any module that want to record log messages or any of your own code will now call that. This we know. Arbitrary identifier settable by the main program. So let's look at it. We have some kind of prefix number of spaces. Okay. Can take arbitrary data pointer. It's gonna be a pointer to an entire data structure that hosts state and whatnot. Copy string message. Right. So here we're using log3 modules basic, which does a print like string formatting, then calls context logger with the result. Yeah, log info. If you set it, maybe you pick a unique ID or hash. Ah, I see. So this is kind of by a convention. It's something I set to know where the log came from, right? So for example, I can do 1 for input module, 2 like for window in module, and stuff like that. Okay, so it's something that I do myself. This I was thinking that maybe it's, you know, getting set somewhere in runtime support, even though I've never seen it happening. Okay. The code that logged the message location, some common flags, and user flags. Right. Cafe babe food face. No dead beef. Not gonna make it. Yes, we have like log flags, which set the log info. We will be using this for sure. Error warning content to file, verbose. Many flags of your own. So I can set user flags. Logging takes time and energy. This is true. Sometimes you might write a data structure that helps with logging. Modules open as a file, reads the line one by one, and passes them to the user code. Because the user code is in charge of knowing how to parse the file, only the user code knows if there is an error. Blah, 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 blah. So it provides functions error and warning. Yeah, so you see, he kind of explicitly blesses you with writing your own log functions, which I think I will be doing because log in basic insists on using a string builder and print and like temp allocator. Yeah. Look at this foreshadowing in how to file. If you don't know what that means, don't write a logger until you do. And runtime support default logger, yeah, it locks like std out, more or less. Nice. So what I think I'm gonna do is so I'm not gonna use logger basic because of this, because it insists on creating a string builder and then getting like a log string by using temporary locator. I don't want to do that from the actual threads. I want to skip all of this and just sub-allocate maybe I can maybe use string builder because it frees itself when you do builder to string, but I definitely want to provide like the final string from the buffer, from this buffer, from the data buffer. That's for sure. And all this crap I might not be using at all. Yeah, so how do we do like, oops, so we do something like using except log. I think that's how you do it. What? Oh no, it's and then let me just copy paste that. Then I'm gonna be modifying that. So you do log this and log error, I guess too. Procedure call matches two possible overloads from logger and from basic. And this means that I now need to route everything through this one. Right, and so I'm gonna import. So it's gonna be using except like this. Hell yeah. And now we're kind of just using log functions from here that don't do anything interesting. So that's a start. Random question, but when you make a custom context struct, does Jai impose any restrictions on how the struct is laid out or members it has, etc? A little bit. Let me show you. So if you go, is it here? Yeah, context base. Oh, it's not here, it's on runtime support. So yeah, here's the context base. Its order is imposed and all user contexts start with context base, right? So this is how every context starts. And all other fields that you add to context, there's a add context directive. So you can add members to the context. All of them will go after this. Yeah, that's basically the answer to your question. But these ones kind of stay unchanged. It's not like inheritance, it's like subtyping. So, you know, if you ever heard composition over inheritance, so this is like the composition. So the context is something like, and this like using as like base. This is more or less how it kind of, yeah. It looks kind of like that. And then my field 1, you know, my field 2 and stuff like that. These are like your fields that you add with using add context directive. Does make sense? Yeah. There you go. And then each thread gets its own context. And if you want this stuff to properly work, you need to do some work yourself. For example, every new context gets initialized with empty temporary storage, which might shoot you in the foot if you use temp allocator with uninitialized one. It will like silently use default heap allocator under the hood, and then you just will leak memory, because you will call reset temporary storage, but since there's no temporary storage, it will do nothing. That's why Jai threading module, it initializes temp storage for you. And also there is remap module that remaps your context in case you want to call DLL functions, right? So you can compile Jai to DLLs, and of course DLL will have a different context, and you need to kind of map contexts when you want to call into the DLL. So the context definitely imposes some complications to the code that make you kind of think about them. And I know, by the way, Ilionte is one of the like biggest context haters, like of the overall kind of concept. It definitely cooked me a couple times, maybe actually more than a couple times. But despite losing maybe, I don't know, like 12 to 20 hours cumulatively to dealing with context issues, I think I still think it's overall a good thing. Yeah. And I'm sorry, people, my throat is like a bit sore because I think the air gets drier, so I'm gonna go and pour myself some more tea. And just go take bathroom break, and you just enjoy the music. It's a bit strange to have such an invasive feature be default, but it makes sense. Yeah, so I like pretty much everything here on the context apart from temporary storage. So literally my only complaint about the context is the temporary storage on it. It is incredibly convenient when you write single-threaded applications. Like, it basically turns Jai into a fucking Python without any of the downsides, right? But as soon as you do DLLs or do multi-threaded stuff, you really need to think about it. But yeah, yeah, about temp storage, yeah. Get cleaned on function exit. No. You need to clean it manually. There is a helper for it. It's called reset temporary storage. Yeah, you need to call this function, and it just kind of drops. It acts as an arena. Yeah, this is one I call auto release temp. You can call it as a macro in a procedure, and then it acts as, you know, as a release, like as an automatic kind of like garbage collection. Yeah. So this works kind of like a garbage collector, and this is the one you usually call like at the end of the frame or something like that. These are incredibly convenient, but I kind of tend to yeah. So I think overall it would be better if temporary storage wasn't on the context. I think if you had to manually initialize temporary storage, even for the main thread, it would kind of encourage you to think more about it, and you wouldn't get cooked by it, you know, inside of the C code. Because my first ever encounter with the food gun was when I was calling temp allocations inside of C calls. So, you know, you enter C call, it was from the Win32 window hook, and I would push context, and I didn't think about the temp storage not being initialized, so I was just using temporary allocator in it. And under the hood, it would use memory, it would use default allocator. And what's even worse than that is that when this happens, this whole situation is invisible to memory debugger. So when I realized that I have huge ass memory leak, I spent like 9 hours, and it was live on stream too. So there's like YouTube bot archive with me trying to get to the bottom of it for 9 fucking hours until I kind of found the issue of, you know, oh, if temp storage is not initialized, it uses default allocator. And by the way, you know, memory debugger just doesn't see it. So it doesn't know the source of the memory leak. So yeah, that was, I guess, you know, if memory debugger handled this situation, then maybe I wouldn't even call that a gotcha, right? But it was just so hard to find that, yeah, it's kind of a big deal. Yeah. But yeah. I'm gonna go take a small break. I'm gonna just run the program so there's something on the screen, even though it's kind of ugly, but it's all I have. I would really want to like work more on UI and work more on like additional features, right? Like just interesting stuff, but unfortunately now I'm kind of stuck with doing like platform Linux code before I release the Linux version. But then Dobby will be free and we'll work on something interesting. But yeah, I'll be back. Also, is music dead? Yeah, music is dead. So let me turn you something else. There you go. I'll be right back. Okay, we back. I got nerd sniped by lighting white paper. So I've been back to working on your bullet hell game instead of your main project. Nice. What's your main project? If it's like not secret. Linux music player. Hoggers. I would definitely benefit. I would definitely benefit from some Linux music player that's, you know, that hopefully isn't called like something MCP, CF, CPCD, MPD, you know? Something with nice UI and not like stupid name that is allergic to vowels. I think I used to use Clementine or something like that. And now, if I am not listening music from YouTube, which also has a lot of downsides, right? I would just use it from VLC, even though VLC has a lot of issues on its own. It's hard to like normalize audio levels. It's hard to like manage playlists in VLC. It's like hard to do a lot of things. I was even thinking, you know, to just straight up fucking run foobar from Vine. I don't know why I stopped using Clementine. I kind of forgot why. I don't remember. Maybe I need to try Clementine again, you know, and see why I'm not using it anymore. Right. Oh. No. Let me... Using except log error. Basic. There you go. That's actually the reason why I'm working on that software rasterizer. It's for the music player. Ah, I see. I see. I was actually thinking about it today. You know, there's a guy, one of the organizers of Better Software Conference. What's his name? Something Malquist. I'm very bad with names, so I have a very good memory for numbers, but my memory for names, especially for, you know, non-Slavic names, is very bad. So at some point I was just memorizing football roosters just to get better at namings. And instead of getting better at namings, I just got good at football fucking roosters. So it doesn't fucking help. Where is it? Fuck. Fucking hell. Charlie Malmquist, yeah. So this guy, yeah, so this guy, he's like working on a new grep software, and he's also organizer of Better Software Conference. And he also said that he makes a CPU rendered. So his UI is CPU rendered, right? Like, look at this. It uses this Windows 2000, Windows 98 style, which I actually quite like. I really enjoy this type of UI. And I was thinking that, you know, I'm not gonna, I'm not like planning to use any sort of hardcore like graphic stuff in my program. I should probably roll software rasterizer as well, because look at this. Like, this shit does nothing, right? Yeah, I mean, it draws some arrows, it draws text, but this is like nothing for modern CPUs. And you can, you know what people do to prevent over rendering on CPU rasterizers? They kind of divide the window, the renderable area, on like quads. And then at the end, before the rendering, you kind of like iterate over quads and you know which of them is dirty. And then you only like bleed these parts. So it's even pretty like, I don't know if trivial the right word, but it's not like super hard to optimize it in this kind of way. And yes, I totally agree about OpenGL. I have custom OpenGL bindings generator that lets you, you know, kind of load all extensions you want at compile time, but you can't really predict the fucking driver that the user will run, right? And Linux people, they run all sorts of hardware and all sorts of software as well. Some of them use like Zinc, which is OpenGL API built on top of Vulkan. Some of them using like GLX, which is X11 specific thing. Some of them use like EGL desktop, some like EGL Glass, and all of them are so fucking buggy. So I'm just, and the Mesa itself, it has like software rendering backend that I think it like turns when it thinks that there's something wrong with like hardware or hardware acceleration in general. So you can avoid all of this stuff, and you can also avoid like linking to GL libraries dynamically if you just do software rendering graphics, because let's be honest, what do you need here? Not much, right? Yeah. And even, you know what can you do? You can still render in software, but you can use like OpenGL or graphical context just for bleeding, right? You can subdivide your frame buffer to like 2 triangles and just like use this as a texture. So you can also do that. Which will probably be like slightly faster than using like shared memory buffer from Wayland, or than using X like image from X11. So I don't know. Because alternative way to do it, I don't know. I mean, how does X image work on X11? Is this because like X server itself does some hardware acceleration under the hood? Why would it be much slower than, you know, X image? You know how I would do that on Wayland? If this is the case, Leonte, I would do that on X11 and let X Wayland handle things. Fuck Wayland. I don't think you can write directly to dmaybuff. No. I'm pretty sure you can't. I think if you try, you probably just like cook the compositor or something. I'm not gonna be surprised if like the compositor fucking crashes or something. If you somehow, you know, if you somehow do it. Right. So we have this. Now let's think about so this thing like this will be something like init log buffer, and this I'll probably just have it as a global here. Log buffer is gonna be can I? Oh, I can't have it as a global here. Well, we'll have it in main. That's Yeah, you know, I guess I'm not gonna do it at compile time. I guess I'll have to just allocate these two as well. Fuck. Because I kind of want to have it as a global here so that these routines can just access it without, you know, without you having to pass them here. Because I want to preserve this, how do you call it? I want to preserve this signature. Hey, 8. Hello, welcome. That's a cute emote. Hello, hello. Currently, a soundtrack from Ape Escape is playing, and Ape Escape 1 was one of the most traumatic experiences in my gaming career. For the stupidest reason possible. The reason being, it was... so my parents bought this game, Ape Escape, for PlayStation 1, and we literally couldn't play it because it required analog input, and we only had controllers with D-pad and without analog sticks, because on PlayStation it was kind of times when, you know, analog just kind of getting like some traction. And the only thing I could do with the game is to boot it and just sit there, like look around with D-pad and listen to this music. And we couldn't afford like new controllers. And it's not even that the fact that new controllers were expensive. We did not even know that there exist some kind of controllers that you can use to play this game. Like, we didn't even know that analog sticks exist at all. We just thought that the game was broken. Because, I mean, how could we know? Actually, this could be a pointer. So this could be a pointer. Then we could allocate the whole thing like this. Right, so something like init log buffer. I don't know, something like this, and you would provide like num clusters as U32 and cluster size, like size per cluster, and all of this stuff kind of goes here. So you have a log buffer here. Just use new. And you returns a pointer to a type. And then you kind of, if log, just kind of have to fuck off, right? Just runtime support. I guess you can just call log error because you just use whatever logger is activated. Would not allocate log buffer. After that, what you do, and so you like num clusters U32 cluster size, yeah. So log buffer num clusters equals num clusters log buffer cluster size. Then you do bytes. Then you allocate them with a line forward. Then you press the count, and then you also need to allocate these two. A lock, I think a lock can also fail. So it returns pointer to void. Yeah, so if not buffer data, or rather if it equals to null, I think it's the same. You can just do like if not, and it will work. I just like to be kind of more explicit. Lock, I mean alloc gulol, but yeah, hello, welcome to the stream. Welcome. If buffer null, log error, could not allocate buffer log buffer storage. After that, we do kind of similar things with right positions. That right positions, and just equal, also like alloc. I guess it's like the same shit, right? With the only difference being it's actually not gonna be this. It's gonna be count. So it's num clusters time of like size of type of like this. Oh. So this is what it's gonna be. And then count equals num clusters. And then same thing for read. Read and write. Hey, Constantinus. I try to feel like I understand something. Same. If you see me typing fast and thinking like, he must be smart, then no, I just can't type fast. The hell. Am I tired of green? No, actually not. I just, I'm just being pretentious with wearing different themes. Could not allocate what? Right positions. Log buffer right positions. And same here, but instead of we do read. So I think that's it. Right, so bytes, data, lock. So data, right position, read position. And actually return false and same. And same. And same. Hey, plus there's something wrong. I wonder what. And then return true. And here we call with 4 clusters and 496 per cluster. And then we call size per cluster. I fucked up. I really hate that. Is it Alt Enter? There was some. Wait, there was some way to open this in line. Compile go to error, push button, compile go to error. Oh, fucking hell. Jump scared me. Hey, Teacup, thanks for the raid. Appreciate it. Appreciate it. Were you playing Silk Song today again, or were you programming? Welcome, welcome, raiders. Hello, hello, dude. Thank you, appreciate it. Mostly Silk Song, but did some programming then. Nice, nice. I hope you enjoy Silk Song. I really liked the game. Whatever. But yeah, we are, so I am implementing a multi-threaded logger today for my program. Finally, a multi-threaded, safe, lockless logging library I can use for my blazing fast cloud-scaled serverless GPU-accelerated to-do list application. Exactly. Yeah, I am actually writing cheats for Hollow Knight. Excuse me, size per cluster is also... Well, not exactly cheats, but I'm writing like... the fuck? Undeclared identifier cluster size. It's not a Oh, it is. It is size per cluster. A buffer, it's gonna be log buffer. And same here. Fuck. If right positions. So 1 second. Bear with me. It's gonna be the same. And mismatch in level of indirection. Type wanted. Type got. So this has to be data. And this has to be data as well. And yeah, this has to be also data. And this has to be data. And I think now we're finally, no. Buffer data count, it's log buffer. There you fucking go. So we have this program. I like the bosses and the movement in Silksong. I don't like the exploration. A lot of people actually the opposite, right? Because exploration is kind of the core of the Metroidvania, like as a genre. So they like the explanation, but then they get walled by bosses and platforming, and then just fucking rage quit. Like, I just want like an easy mode where I can enjoy the story, you know, look at the backdrops. And that's it. And I guess you're the opposite, which makes sense because you often play these like high-paced, you know, like kind of skill ceiling games. So yeah, I can understand where I don't know where to go just kind of distracts you from what you actually want from the game, right? But anyway, what we have here, what we're dealing with here is total lack of respect for the law. Yeah, we have this program that lets you map your keys on the keyboard. You can map them in a simple way. So, you know, you can, for example, map U to escape. So every time you press U, you get escape at the end. And you can also do this. It's kind of like, you know, arcade hitboxes let you override buttons when you press them at the same time. So whichever you press last kind of comes on top. So you can use this opposite mode for frame perfect turnarounds. And let me actually demonstrate it to you. So I'm not gonna demonstrate it on Silksong in case, you know, spoilers, because my save is like 100% completed. But I will run Hollow Knight, the older game. And let me move the window here. I have per program profiles. Right, so this profile only activates when Hollow Knight window is focused. And yeah. So I have movement on WASD, so I'm pressing A. And while still pressing A, I start holding D, and you can see how like I'm just holding A and tapping D, and I get this like crazy turnarounds. And you can use it to like do like air stalls and stuff. So you can like turn around in place. Also in speedrunning we use like nail turnaround. So you can normally hit with nail, but if you cancel your nail animation with turnarounds, so like this, you can hit like, I think it's 16% more often, and this helps, and it's like legal and allowed. And then P is mapped to another L. This is like for double jump, so you normally can press double jump, and normally when you press double jump you get this kind of dip, a little bit of a dip in the game, right? So, right, let's go here. Like, you get a bit of a dip, but if you do it fast enough, you can have a double jump without any like dip, so it's like an instant wings, like this. And you can achieve it by rolling fingers real quick on the same button, or by sliding your finger from one button to the other one. And so in my case, it's like P and L. So if I slide my finger from P to L, I get the same effect. So it's kind of like this. And you can have like, you know, like crazy wall climbs. Yeah, it's still kind of, you still need to have skill to get it. But yeah, you can see how fast you can climb. Yeah, and that's kind of the gist of this program. It just lets you do this stuff. And it's for gaming mostly, but it also lets you do stuff, for example, like map your caps lock to control, and yeah, there you go, caps lock map to control. It's just a common thing people do, right? And I am currently working on Linux version, as you can see. The software is called Hitboxer, and it's actually shipped for Windows, so you can download it for Windows and use it if you want. But yeah, Linux version needs some work before I can push it to people. So there you go. And today, as I said, I'm working on different logging setup, so I can log safely from multiple threads and like put it into a log file, and at the same time to its std out, and maybe at the same time show errors in the UI itself. Mapping scroll wheel to various things. Yes, mouse support. I don't support mouse yet, but it is trivial to add. In the way my program is programmed, adding mouse support is trivial, and it is planned, yeah. So my plan is to support mouse, keyboard, and controllers. Controllers are a bit harder because you can emulate controllers on Linux in user space, but on Windows you actually cannot. So Windows has keyboard and mouse hooks that you can hook into and output events to any program. But for controllers, you have to write a kernel mode driver if you want to emulate them. So it is impossible to do in user space. And you know what it means? It means that if a user wants to use your program, they have to either change like security settings to let you load unsigned driver, or you must pay to Microsoft. And it's like, at the very least, it's like $150 a year or some shit like that. Alternatively, you can use an abandonware. So there is actually a signed driver that's called like this. I was just about to say that. So there is this thing. It's called Vegan Bus, that actually a lot of projects use, but it was abandoned because of copyright issues. We had an incredibly smart furry giving us high quality Windows kernel mode driver for emulating controllers and providing programmable API, but they got pissed by some company in Germany, and they literally like kind of, I don't know if it was a rage quit or not, but they basically abandoned this project. And this was the only free and open source and signed thing that a lot of other projects were using. For example, DS for Windows. DS for Windows, it's a very like popular DualShock 4 driver for Windows, was using this thing, and it also got retired because of that. retiring of this project, it kind of killed a lot of downstream projects, and it is functional still. Yes, it is functional, but you know what you know what I mean. It is only functional because, like, as long as Microsoft doesn't change anything, right? As soon as Microsoft changes something, it will break. So it's like, it works only because Microsoft has like a very good backwards compatibility story. And on top of that, I think there's some issue with updater for this driver. There was... Oh, I think they had to give away the domain because of copyright dispute, and now, like, if you install this, it's like technically a bit sketchy, because I think inside of the code it like relies on a domain for updates that they don't see here, like for some reason, right? Let's say I'm fine with it. For me to replicate this functionality, I mean, at the same level of robustness, I would need to spend like a fucking year to master all this crap. Just look at this. Like, GitHub can't even fucking open it. Oh yeah, Imgurlink, sorry, I forgot about it. Indie game developer. While GitHub is opening. Rigger, music producer, UX designer, CEO. Yeah, this is true. This is very true. I mean, sometimes you get lucky and you have like two friends that are very talented, right? One of them can be, let's say, insanely cracked artist, like one of the best artists in the industry, right? And let's say another one is insanely good composer and music producer, right? Let's say you have two friends like this, and you are like an okay programmer, like you can write code, whatever. If that's your situation, then you become Team Cherry. And you can write games like Hollow Knight and like Silksong. And then, even if you're a shitty programmer, you can write Hollow Knight that will do so incredibly well, despite of it being very poorly written, that you can hire a fourth guy who is actually a career programmer, who will optimize your first game and help you write the second game in a way that works really well out of the box. And if you do everything yourself, yes, you become Billy Bassdu. Yeah. Then you become Billy Basso. Exactly. You will not have the scale of Hollow Knight, but yeah, you will still make a very good game. But I am no Billy Basso. Yeah, I'm just like a mediocre web monkey. And yeah, look at this. This is fucking DualShock driver. Just look at this. It's actually not that much code. It's just 1,500 lines of code, but I bet there's like a lot of stuff here. There's like a lot of knowledge packed here. Also, what license? How is this licensed by? It's well, at least, you know, if I decide to do this, if I decide to write a kernel mode driver for Windows, at least I can use this not only as a reference, but literally borrowing the code. Yeah, but I don't have furry powers. I just don't have that. So unfortunately, I I won't be able to reach this level of quality. And from what I've heard, this is actually a very like high quality driver. Because I know I've used DS for Windows myself, and it was literally better than Steam like virtual controller. And it uses this thing. Yeah, so like this gets me really radicalized against bureaucracy. Like, can you imagine you've been like just like a chill dude working on a very like cool software, and then some fucking ass like lawyer comes to you and becomes a party cheater, party pooper. Oh. Like never offend a furry who works on low level software. Brony and furry. Who the fuck is Brony? Adult, particularly male fan of the animated television series My Little Pony. Oh, I knew who Bronies are. Yeah, I just forgot about it. Yeah, I've definitely heard that before. Yeah. Yeah. So this is... Oh, this is... Yeah, it is. It is somebody from My Little Pony. Okay. Yeah. Yeah, maybe they are a brony, not a furry. But yeah, so... Anyway. Never offend a low-level programmer who is into 2D cartoons, I guess. Come on, like, not gonna fucking stalk a guy on stream. I already done enough damage. Anyway, yeah, init logger. Let's get back. Let's get back to multi-threaded logger situation. So yeah, we like init a buffer, right? If log error would not initialize the logger. Would not initialize the logger. The logging will be crappy. Yeah. So we don't have this message, so we're fine. Yes, exactly. Cloud scale, yeah. Web scale, cloud scale, all this thing that we all love. Especially now, since Vercel got into hot waters, we need to provide a good logging alternative. So we are working on it. Right. And I think actually I guess that's kind of it. Yeah. So today I'm working on this, the thing that we outlined yesterday. I have multiple threads that will call log, and my new logger that writes to file is not synchronized like at all. And I also have log rotation on top of that. So, and I actually was able to reproduce a race condition when two of the threads rotate the log at the same time, and they just kind of destroy all the information in the log file. Yeah, log into the file from multiple threads, exactly. And also in a way that's non-blocking, right? Because now, if I call log from my very hot input handling thread, it starts like string allocating from temp storage, and also writing to file, right? Like input thread that's supposed to work like really fast now writes to file. What the fuck? So yeah, not gonna do it. So what we do instead is we init log buffer, and then we need to provide some kind of helper functions on top of just initting it for it to actually like fucking work. So for example, let's say you call, why not just queue the logs and write from just one of the threads? That's the idea. Yes, I'm gonna queue logs from all of the threads into this queue. So this is kind of a queue. And then one thread will actually do the logging. So yeah, that's the idea. Yeah, that's exactly the idea. So all of the threads, they still keep calling the log, but under the hood, this log, it will kind of use this memory storage by sub-allocating this buffer. Each thread will have its like section of this buffer, and then there will be another thread that will like, I guess for Linux we're gonna use eventfd that we will poll on, so it's blocking, and it will write into the buffer and then trigger the eventfd so the other thread wakes up. Kind of like that. So let's say we call this. How do I structure it in memory? Like if I just call it with string, because I don't want to use a string builder inside of my input handling thread. I want instead to do something like so first of all, I need to know like which section of the buffer this thing belongs to. Can I use thread? So let me do this. Let me not do any like stuff, and also when I log my logger, can I not write to file? Yeah, let me do this. So instead of doing all that, I'll just like I'll just write this to default logger unconditionally for now. Yeah, just like this. And let's say I want to print thread ID. Can I do this? Context thread ID. I think that's what you need to do. Is it? It is not. Ah, it's thread index. It's not thread ID. Wait, what? Module parameters can only be used at the top. The fuck? Did I nuke something here? Wait, what happened? Oh, because I'm trying to compile from the wrong thing, yeah. Thread ID 000, thread ID 3, 000 Yeah, okay. So this is the input handling thread that is grabbing stuff. Also, focus thread is 3. This one is also, if I add mapping. So let's check, let's say I switch profile. This is also 0. How come it comes from the main thread? That's weird. Let's say I'm adding profile for Krita. Yeah, I mean this is 0. This is actually fine because this is in fact the main thread, and the input handling thread. Oh, let me actually log this. I know what's wrong. Linux print. Yeah, let's log it instead of printing. Oh shit, what the fuck is this? Memory debugging error. We somehow got an allocation for address that the memory debugging system thought still alive. Anyway, but yeah, now thread number 2, yeah. Logs key presses. This is expected, so 0 is the main thread. This stuff happens before we initialize any logging somehow. This thing happens inside of the log error. By the way, I apologize for the fruit salad. It's just Emacs compilation mode tries to parse these as file and line numbers. What is thread number 1 then? So I have 0, I have 2 and 3. Who's 1? Who's 1 and also... Oh, now it's all good. Huh. Yeah, so second one does the input handling. And let's do... Oh. Init platform init, yeah. So here the... Oh, it's probably the timer, handle timers. So let me log... So it only logs errors here. Else timer FD. Let's log. And we do something like... I know, timer FD created. Let's see if it's number 1. Yeah, look at this. Number 1, timer FD created. Easy clap. So 0 main, second one is timers, then third one does the inputs, yeah, TAD2, and then 3 is focused situation. So I guess I can just use thread index here to subdivide, and I assume that thread index is consistent, so this is probably a good thing. It also means that I don't need to provide this as an argument here. I probably can at some point, so if this ends up being unreliable, then I will provide it. Now, we need to subdivide the data. So how do I do it? Let's say I get format string. And then the arguments. How do I process them? So I have like a write position. I need to add to it, like length of the string. So I need to add to it like length of the string, and then not actually length of the string, but length of formatted string. And then check that I actually have the required amount of memory in this sub-region of the buffer. And then when I write the next, and then after I write, I need to move the right position to the point where I've written. And if it like wraps around, I need to drop it back to 0. Right? Yeah, that sounds right. So it's gotta be something like right position equals to log buffer right positions, and we use cluster context thread index, right? And we do cluster. And this will crash if we get out of bounds, which is fine. We get right position, which is a number. Then how do we get a byte offset from the data? Where is it? Data. So 0, 1, 2, 3, 4, 5. So let's say, let's take the easy approach and first let it do this. Let it get the string. And for example, we go here and so like length is gonna be as.count. And we need to do something like assert WP, so right position plus length. It should be less or equal than log buffer So right position. Actually, right position is not this. Right position is right positions times cluster. Yeah, because first one will be from 0 to 4K. Second one will be from 4K to 9K, then to like 12K, then to like 16K. You know what I mean? Because again, this is how the clusters get subdivided in the buffer. And so we're looking for this for the first thread and this for the second one. So we need it like times cluster. And here's gonna be our right position. And we need to be right position plus length should be less than equal than log buffer I guess this so we need to normalize it. Mine less than equal than cluster size, yeah. Right? No, not the cluster size. Like it needs to be not the cluster size, but the remaining cluster size. Oh, I'm like so bad at this kind of math. This is what I like never do professionally, so this is just something I need to sit through and think about it. Right, so we have a buffer. Each cluster has 4K, for example, and in my case it's like literally 4K, yeah, because this is how I initialized it. So we get WP plus length. And it should be within like bounds of its cluster. Actually, I think, yeah, it's true. So this should not exceed 4K, basically. And I guess, is this like divided by cluster? Is it it? Is that it? So if it's cluster number... No, if it's cluster number 0, it will just destroy. So we do this, plus length, cluster size. This is the one, so... I know. So cluster size plus like cluster size times cluster. Does it make sense to you? So we see that the amount of memory we sub-allocating does not exceed the boundaries of the cluster. And we calculate the boundaries of the cluster as cluster size, so 4K, plus the offset of the cluster. Yeah. And let me be like super explicit about it and maybe just like straight up print this shit. So print thread ID, then we print we print here. So print thread ID and then right position, and then we print length. Let's do commas. Length and the boundaries, right? So I want to print kind of this thing. So I want to print this thing. So this is like a cluster boundary. Log buffer cluster size. So for example, 4K plus this. Yeah, and also this is not correct because if the cluster is first one, so 0, this will always be 0, which means that you need to get this position and you need to do it like plus cluster times, yeah. So you need to do this as well here. Yeah. And then cluster boundaries, so length and cluster boundary, right? Let's then cluster boundary. And let's say then we do something like actually suballocate here, and then after this we need to do log buffer WP equals to what? To WP plus length, I guess. And this for now, this doesn't consider wraparound. So at some point I want to expect this assert to hit. So let's run it. Type mismatch between arguments, left S32, right U32. Why did I make it? Why did I make it S32 for these? Because in case they underflow, I get -1 instead of hugest number. So maybe let's do this also signed. Like, why the fuck not? Who cares? Right positions. Cluster size times cluster. What? Log buffer cluster size. Right positions cluster. Hey Owlman, hello. Yeah, welcome to the over-engineered team. Oh, fuck. Yeah, we are over-engineering. Maybe a little bit over, maybe a little bit out of my pay range. But we're getting there. Why the fuck does it... Why is it a signedness mismatch? Oh, is it because thread index is a U32? Yes, thread index is a U32. Well, abort the mission. Let's get this back to U32 and get the previous compile error. Left one is S32. Let's do this. WP is not a member because it's supposed to be right positions. It's right positions cluster equals length. Is it? Yeah, it's length. This is the right spelling, right? Yeah, it is. Sorry, it's English brain fart. Number sinus, type wanted, type given, x64. Why? Oh, because this is a count. And I think this will complain that we loss of information. No, it's not. Okay. So we have thread ID 1, 4096, a right pointer, and length 17, timer FD created. Then we have thread ID 0, 0, 39, thread ID 0, 39, 28, 67, 41, 108, 28, 136, 79. So this is actually kind of advancing and it looks like it's correct. Or should it be +1? Well, whether we did off by 1 error or not, we actually will be able to see as soon as we start printing. That will be actually pretty easy to catch. And stack trace, there you go. Right, and finally, where are we? So thread number 2, right pointer is 16 for... Yeah, this is not good. Why is that? So 2, this is the start, 22. Oh, the fuck? Why is it suddenly so big? So this is fine. And it should add 22 to this. So next logging from this thread should use right pointer that is 8192 plus 22 and not this crazy number. Let's check what's going on here. So we use cluster, which is like 2, right? So like log buffer, right positions, cluster, plus cluster size times cluster. Okay. And we have like cluster boundary. 1, 2, 3. 1, 2, 3. Oh, I haven't printed the boundary. Boundary is... I haven't printed the boundary, so... This plus length less than, so... Equals this plus length. Oh, yeah. I see. So, wait, no. Right. This is... Right, this is because we did not initialize all of the writing positions. So at the start, all of our writing positions are set to 0. So all of these get start from 0, which it actually shouldn't really matter because we normalize them here, right? Because this uses cluster size times cluster, which should technically normalize them. So I don't think that should matter at all. Let's actually check it again. Yeah, stack trace, nice. Boom, boom, boom. So this is our boundary. 12, 12, blah, blah, blah. And then we have this crazy stuff. I know what's going on, I think. Yeah, this is because of the normalization. So we normalize when this is 0, but then this kind of hits us. So we should actually don't do... we should initialize that when we initialize the buffer, set all the writing positions. And we don't do anything here. Actually, when we... So yeah, look at this. After we initialize read and write positions on buffer creation, we need to do like a range here. So for 0 to num clusters, and I guess -1, because in Jai ranges are inclusive. What we do is log buffer dot write positions it equals Basically that. And same with read. Yeah. And this is where somebody would use this like crazy syntax in Jai to align them properly. Yeah, in Jai you can put backslash in the middle of an identifier, and then add like white spaces, and the parser will just eat that out of an identifier. I'm a big backslash hater, yeah, because it complicates grep for like no fucking reason. You know, like a regular text-based grep. Because now you have to add like regular expressions to your grep. Which is, it's not hard, it's just why. And you know, my kind of argument, if you really want to align these, why don't you do that? Like, just do this if you want to align them. Or no, maybe you can do that. Can you do this? Like, will this work? It's not cluster, it's times it. No. It literally works. Yeah. So it literally works like this. Yeah, I almost never align. I would sometimes align fields in the struct, rarely, like on rare occasions. So this, I think, is fine. Like, I don't mind alignment like that. But aligning declarations, I don't know, like, yeah, I would align by equal sign or something, but not on underscores. This is some like levels of OCD that are inaccessible to me. So I would never use this feature myself. For sure. And I know that, you know, eventually when everybody just use LSP, it will just work because you will get identifiers from either a parser or from like meta program. But still. Yeah, I'm gonna refuse. I'm a big hater of this feature, for sure. Anyway, so this, we initialize write and read position, so every of them is like offset by the size of the cluster. And I think now we shouldn't assert anymore. Yeah, look at this. Boundary is the same, but yeah, this gets, you know, gets bumped. Gets bumped, and eventually, if we do too much, and even more, now we crash. Yeah, now we assert, because we went out of bounds, you see. So this and length 21, it just wouldn't fit. So what we need to do here is we need to actually wrap around, because remember, I wanted to be a clustered ring buffer. And for people who just arrived, so each thread will have a chunk of this buffer subdivided to them, and it will use this like chunk as a ring buffer. When it goes to the end, it needs to wrap around. It's like right position. Yeah. Yep. So what it needs to do is when you log, you need to get right position, and it's like modular, right? Modular what? Modular the boundary, actually. Any memory mapping. Yes, so the idea is, right, multiple threads, they just write to this buffer without any sort of blocking. And then the consumer thread will just know how this shit is subdivided and just read from it. Yo, Doomka, hello. Usually just virtually map to ring buffer. Oh, are you telling me that like operating system gives you like ring buffer for free? If that's the case, I need to man a map. Okay. So it's not like a feature. It's not like a feature of map. Okay, I see. Yeah, so I didn't want to have a ring buffer like per thread, because it means that my reader would have to like iterate over all of these ring buffers, and like read them, and it means that I also have to allocate all of these buffers separately, right? And I thought that maybe if I just allocate a contiguous chunk of memory and subdivide it, it maybe like will save me some code. Yeah, so because this is essentially the same thing, it's just I'm allocating them all at once and then manage the wraparound myself. But if you have an implementation, I mean, feel free to drop it. Why not? Hey Maria, hello. As you can see, we're working on the Luger. I hope you've been doing well, Doomka. I've seen you playing Bloodborne. I assume on like emulator, because it looked way too fucking crisp for it to be played on PS4. So I assumed it's an emulated one. DM'd it on Discord. I mean, you could just drop it in Discord. It's because it's like a file. Can I just drag and drop it? Like this? Can I just drag and drop it? No, it will drop it like a link. Okay. Projects, SOCD, modules, save. Let's look at it. Играю на карте захвата. I see. Okay. Yes. You need to be very careful about your wording when you're dealing with Japanese gaming companies, am I right? You made a whiteboarding app because you got annoyed with Krita. I see. Well, that's what happened. What happens when you annoy a programmer, right? Programmers tend to just do things. So I have memory capacity tailhead. Oh, look at this. I kind of almost YOLO'd it, because I also have write and read positions. So this is like heads, multiple. This is like tails. Right? Yeah. I don't have a capacity. And my memory is this, not void pointer. use align to granularity. Yeah, I use align forward from basic. Oh, this is the resize. Allocate mirrored? So this is the one I want to look at, right? Holy fucking shit. That's crazy. Let's look at Linux API because I'm just more familiar with it. Hey, what's that? Why do you unmap it first? Oh, because it's like, yeah, it's re-entrant, right? Where does it get memory from? Ah, use it's resize. Never mind, it's resize. Yeah, I need to look at allocate. One from Casey. Oh shit. Capacity location. Why do you need location just for logging? Anyway, open hand. The fuck? You create memfd. Okay. Then you truncate it. Yeah, I know this. So you map some memory with no protections, blah, blah, blah. Yeah, you return it. Okay, then you use some like fucking handle. That use what? What the fuck is going on here? Handle. Memory plus capacity. Huh. So you do address and then length. Address length. And then you do kind of the next one. So you allocate two different memory pointers. One is at the memory and another one is right next to it. Right? Like one next to it. But I mean, this doesn't allocate it on this. This is just like. What does it do with the handle exactly? Handle. Why do you need handle again? FD. Why do you need FD? Where is FD documentation? Other properties. Ah, after map call has returned, the file descriptor FD can be closed. Why the fuck do you need FD? Okay. So the contents of a file mapping as opposed to an anonymous mapping are initialized using the length bytes starting at offset. In the file, referred to by the file descriptor FD. So you also need the offset. Offset is 0 here. So allocate it and it starts from offset 0 at this handle. And then you allocate. In the same file handle, but also. And so this just works? So, because naively, if I would just read the code, this would kind of weird me out. Like, how does this work? Where do you actually commit it? So this one you just allocate. Okay. Hey, here's capacity times 2. All right. Yeah. I see. So this is capacity times 2. And this is an anonymous one. So this is not backed by any sort of file descriptor. And then you pass this exact memory into map. And then let me check it. Open handle. You get memfd. Let me check like memfd. What the fuck does it do? Creates an anonymous file and returns a file descriptor that refers to it. File behaves like a regular file, blah blah blah, modified. Unlike regular file, it lives in RAM and has a volatile backing storage. Once all references to the file are dropped, it is automatically released. Anonymous memory is used for all backing. Therefore, files created by memfd have the same semantics. So yeah, you see, so okay, so this is just so you can yeah, so you get just file descriptor that you can refer to later. Right, and then you allocate a memory of double the capacity. Then you pass this memory into mirrored memory. So this one is already allocated. And then you just map this allocated memory into the handle. So this is just bounce this memory into the handle, right? So, and you allocated double the capacity, but you only map half of it to the beginning. And then you allocate the second half of it again at the beginning. Wait, no, this is not the second half of it. This is address. Yeah, this is like an address of a second half of the allocation. You just allocate it again at the beginning. Yeah, second call puts the first half of reserved range into the FD, and you give the same FD to the third call to have them both point at the same range. Yeah. Yeah, I see. Let me check. I just got a message. Okay. Yeah. I see. So I see what it's doing. I'm just not entirely sure why it works, right? Because so it doesn't look like it's a ring buffer. It's just like memory that you divide in half and you kind of layer on top of each other. Does it mean that if you allocate more like double the capacity to just go out of memory, or how does it work? So I see what this code is doing. It's the memory you build a ring buffer upon. You don't need to worry about write wrapping. But how do you not go out of memory then? And why, and then, you know, like, so yeah, I see what this is doing. I know what this code is doing now. I just don't understand why it works. Yeah, you can get a pointer at 2000 and write 4096 guarantee in it always is in range, yeah. As long as you allocate less than capacity. Mm-hmm. Okay, now it makes sense. Now it makes sense. So there is a caveat. Yeah, yeah, yeah. Okay, I see. So allocating double the capacity just like layers the second allocation on top of it. And so if you go out of bounds for the first one, it kind of uses the beginning of it, yeah, overwriting the previous allocation in the first layer. Yeah, and as long as you don't like exceed actually shouldn't you be able to allocate more than capacity? Yeah. Shouldn't you be able to write more than capacity? Because you have like double the size. Ah, no. If you, yeah, I see. So if you allocate more than capacity, you will fucking override the beginning of the allocation, right? So it doesn't work like that. Yeah, I see. Yeah. It won't work. It won't work, yeah. It will only work if you write from this, like from the start. Yeah. Yes, exactly. Yes, I understand it now. Now I understand. Thank you. Thank you for helping me to process it. That's some fucking cursed tricks, not gonna lie. um, I don't want to use it because I don't expect the actual allocation to wrap around. So this has an interesting property. This has an interesting property of the fact that a single allocation can wrap. My implementation, I did not plan this for my implementation. In my implementation, what I was thinking is that if the allocation goes out of bounds, you will just start it from scratch and allocate the previous memory. You know what I mean? Yeah, so this was my idea. So it means that I will like waste some memory. Well, I will only waste some memory if my actual allocations are not like divided by the cluster amount. Yeah, so in this case, I will just waste some of the tail memory, which I think maybe is okay. But yeah, this is actually an interesting property I might think about. But again, it means that I will need to allocate separate ring buffers. So instead of using a contiguous memory, I would have to have buffers like write and read positions. So let me experiment with this first, and if I don't like how it behaves, I will do that. Yeah. Command data storage. Yeah, I see. Yeah, in audio you always use ring buffers, right? I mean, because that's what you do. and since audio is temporal, you literally don't need whatever is on the head. So yeah, I mean, audio and ring buffers kind of go together. Yeah, and networking makes sense, and also in like I/O, which I guess I/O you ring, it literally has like ring in the name. Yeah, networking, which includes I/O, like file I/O. That's why, yeah, I/O you ring in Linux is literally called that. Because it is backed by a ring buffer, like from the kernel. I'm gonna take another bathroom break, and then I will implement rapid logic. I don't want to take, like, you can look at it yourself. I can give you, so here's the start of Linux implementation, right? And map view, so this is the, yeah, here. Enjoy yourself. I'm gonna be right back. Let me put on BRB. Yeah, hopefully it doesn't, but let me be nicer. It's like, yeah, so you can read the code, you know. Okay, enjoy. So, did you enjoy it? Damn, like Rayman games had some bangers in them, didn't they? Let's do something more a bit. I need a little bit more energy to continue working on it. Let's do this one. Right, so I'm not gonna use it now, but we might try it if I, for example, don't like how memory behaves here, because, for example, as I said, I expect if I will have arbitrary suballocations from here, it means that I will often probably have a situation where on the tail end of the boundary per cluster, I will have some memory wastage. So I might not like it at the end. We'll see how it goes. So we have log, we have boundary, and then we need to, we need to wrap here. And how do you wrap? How do you wrap? Actually, I think it's pretty easy. I don't even wrap. Like, I don't wrap. I just literally do this. So I get this, I get length. And if WP plus length is greater than cluster boundary, I just do WP equals to this. And this should be like times cluster. That's it. I just start from scratch. Yeah, that's like it. Hey Connor, hello, welcome. Because shared memory open requires a name. And you just use location as a name. Yeah, that's pretty funny. You could use like file name plus location, but yeah. Well, I mean, it's one way to fix it, right? Excuse me. I should probably end soon because my throat gets even more sore. Yeah, file name plus line number, witty print, yeah. So, surely I can do this without... surely I can do this without if statement. I can just do this plus length and like mod right? This is the same thing, right? Wait, no. It's not the same thing. Because this will always fucking wrap to 0. Yeah. It shouldn't be modulo. It shouldn't be modulo cluster boundary. It should be like my head. I'm like fucking head. So it should be like modulo actually I think it might be fine. Will it? Let me bust the calculator up. So if we have right position equals 1 and then length, how do you fucking spell length? It's TH. Why am I right? I'm like the whole day I'm writing it like HT. What's wrong with me? I don't like 200 and then boundary equals to I don't like 300 and then I get like WP plus length 201, right? And so next one will be English moment, yeah. So WP, new WP equals 201. Let's say, and now we do WP plus another length is gonna be this. And then I am like modulo boundary. It's gonna be 101. So this, I don't want that. I actually want to start it from 0. And 201 modulo 300 is gonna be 201, so this is correct. But when it wraps around, I actually want to drop it to 0, not to 101. So this has to be so kind of length goes by is it minus boundary? No. It's gonna be for 101. How do you make it 0? No. I'm not losing. So if I approach the boundary at the end, and if new allocation doesn't fit the boundary, I want to start it from 0. That's the idea. And yeah, I will have some wastage at the end, but it's like whatever. For now, I want to do it like this. Later, I think I'm gonna, I might just switch to like typed log instead, to like log enum or whatnot. Yeah, I think this is fine because I don't think there is a math you can do to just drop it to 0, right? I mean, I'm not only prototyping, I also want to kind of learn how to do it, even like properly. So I'm not like necessarily, so I'm not even necessarily want to make it work, you know, as soon as I can. I want to sort of explore a lot of ideas. Yeah, same for me. It's like 1:30 in the morning, so my brain is like, whoa, already. And this is every day for me. This is how I stream. I stream while already kind of past that time. But if I don't stream, I just don't work on it. So I pretty much I can only work on it when I stream. So yeah, let's just do this. Plus length. No? No, this is what we do. How was it? Yeah, we'll do this. There you go. So we get right pointer. If this doesn't fit, we wrap it around. And then let's cluster boundary is used. Yeah, you are absolutely correct. Wait, what statements in block after return? I declared identifier its cluster. So there we go. So we have boundary is 12k. Look at this. So 11. So and we wrapped around. Look at this. So 12,273. Boundary is 12,288. 15 doesn't quite fit. So we have a little bit of a bytes wasted. And so instead we wrap around and we start from scratch. So yeah, this works as intended. This was the idea. So it wraps within its little section. That's the idea. And let me kind of document it, I guess, a little bit for me tomorrow. If the sub allocation doesn't fit in the cluster, we don't wrap it as in a real ring buffer. We just reset right position to the start of the cluster. If the sub-allocation doesn't fit into the cluster's boundary, we don't wrap it as in a real ring buffer. We just reset right position to the start of that cluster. Nice. So this is gonna be some log situation. Then this assert will kind of help us. And I guess I can do right? Is this how you do it? Or do you just like sprint it? How does assert work? Me forgot. Oh, it needs to be pre-formatted. No? No, it does not, so it can just be... So it just uses tprint under the hood, so I can do this. I actually have my own assert that doesn't require you to, you know, kind of like expensively pre-calculate all of that. it actually accepts this as a code and inserts it like intelligently if it's required. So I might bring it into this project. Yeah. So now we assume that suballocations will work. So how do we actually suballocate now? Yeah, thank you for the ring buffer, and have a good night. I'm gonna actually log off soon too. I just want to see how suballocations work. Yeah, and then I'll probably log off. So you see, right, so we have this buffer, and we need to get like its memory. So maybe like having it as a array view, maybe we don't need that. Maybe you could just use it as a void pointer instead, right? On the other hand, we kind of have a count, so we can always inspect it as a count instead of having to, you know, have this be like calculated constantly. So I guess let's rack it for now. So the way we suballocate it is actually, you know what we can do? So when you print to builder, where the fuck you print to builder? Builder to string. Does it have any sort of I can have my own little allocator that will do all this magic, right? That will literally do all this magic and give the memory. So maybe I need to wrap all this logic into like allocator interface. Let's see how this works. I looked at it before, I just kind of forgot. So, here you go. So builder string length. So I can call this to know how much I need. The overall idea is to get rid of string builder from this particular function like at all. I would much rather put format string and also args into the memory. The issue is that args can literally be anything. Any injai is a struct that holds a pointer to value and its type info. And how would I store that exactly? You know what I mean? Like, how would I store that exactly? If I were to fully... Like, I probably just wouldn't. So args is kind of a slice. I could, you know, what I could do is I could store format string in the buffer, and then I could also store this amount of any's right next to string. I could do that. Right next to format string, I mean. I could do that, and then on the receiving end, I would have to pass the string count and this count separately. Oh, excuse me, which is like a lot of metadata that I don't want to manage for now. So I guess for now we're gonna use this kind of clutch, with the only exception that we, instead of using temp allocator, that uses alloc here. The fuck is extra bytes to prepend? Ah, yeah, this is the one. Extra space at the beginning, so you can do something like put in a link that you didn't know where you were writing out the data. I think, so look at this to do. For heavy duty use, you probably want something like the string builder bucket stealing that is in the compiler source hasn't been. You know what? This is old to do. You know why? Because it was added to Jai. Because now you can append and steal buffers. Yeah. So this is actually just an outdated to do. Because this was implemented and I've never seen this used. Yeah, so instead of using this, you would allocate another string builder and then you would steal buffers of this string builder. That's what I do in my OpenGL generator, for example. So yeah, this is like super outdated. How does it even get used? Ah, so it's allocated and then gets managed here, and then you add it to result in that data. Okay, yeah. So what I would do, this like calls alloc of count, which I would suballocate from my array. And it would like get put on here. Oh, I could even use it for printing to builder. So I could maybe use it as a backing storage for builder itself. Can I? Let me think about it. Yes, I can actually. I would just use the same region of memory twice. Unless it will make the builder itself kind of barf. So, how does it work? So it gets the buffer and then it mem copies from data to data from this. So my idea is that I overlay the memory of the initial string builder with the resulting string. And this, I guess it should work because the beginnings of the strings will always align. And like, if anything, the resulting string should be either the same length as all of the strings in the string builder, or it will be shorter. Also, I just realized, why would it use print to builder? Why the complexity of string builder? Why not use... Right, so if you're gonna use temporary locator, why not use tprint right away? Why do it like this? Let me check basic again. Not basic itself, print. Am I missing something? Why do you do this? You know, so why this instead of stprint? You know, so format string args. Why not this? Was tprint just not implemented yet? Yeah, it's literally the same thing. Look at this. It's literally doing the same thing. So I guess my assumption is that string builder just wasn't implemented yet. I wonder if that's the case. It looks like the only difference is that temporary allocator also is used for the builder itself, but it doesn't matter because when you call builder to string, the builder will free all of its buffers when it copies to string. So this essentially does exactly the same thing. So if I were to guess, log was implemented before tprint. So I can just remove this and use tprint. Format string args. Literally, unless I'm missing something. Yeah, so I can do this. And like it uses string builder regardless. So let me check the so it gets a base buffer and then it copies the data from this to this. And so if I use wait a second, what? Yeah, let's actually check print to builder. Print. Wait, where's print to builder? Huh? Why is print to builder not in string builder? That's so weird. Excuse me. I'm gonna fucking sneeze. No. Hodl. I'm... Gesundheit. Yeah. Hey, Ian. Hello. So yeah, what does it do? Bunch of assembly do it. No, it's too late. So yeah, this just executes a logic of like where does it do suballocations? Format string. So append, there you go. No, if char not equals %. Then it depends the percent. Printed cursor minus printed, then it skips shit. Okay, so append is where an actual logic happens. Append. No? So there you go. Data count. Data count, there you go. Focus still. Yeah. What do you want from me? Like I need modal editing, which is not in the focus, and a few other things that I'm using Emacs for specifically. Namely, I actually rely on Emacs for Git UI. And this will never be in focus for obvious reasons, right? I mean, I know I can use Emacs just for Git integration. Like, I think even if I eventually switch to other editor, I will still keep using Emacs for Magit, because it's literally the best like Git UI I've ever tried. So yeah. But actually the main thing I'm missing, so let's say we leave Git UI out of the equation, right? What do I need? I need modal editing support. You know, not necessarily like full-fledged Vim emulation, but just something that lets me switch modes and assign key maps. Because that's what Evil Mode does essentially. It uses, so Evil Mode just uses Emacs facilities to implement modal support that's like Vim-like. So I need that. I of course need indentation. I don't remember if Focus has automatic indentation now. I had automatic indentation in my personal Focus fork, but it was pretty shitty. I like hacked it in. I think I talked about it, I think with Obivanus, and he said that, oh, the way it's implemented like in Focus kind of not very good, we need to rewrite it, blah blah blah. And also what else do I need? Other than that, I need hippie expand. I don't know if hippie expand is a common term, but it's basically simple word completion across all the open buffers, right? So for example, if I open here and I do log underscore, I can, you know, log buffer error flag section info, you see what I mean? And it also actually shows me here down below, so expansion found in, yes, I actually rely on this, so I can do append, then like by pointer, you see? And I do append underscore, and then I can iterate over all of the, and it scrapes it across all of the open buffers. And this is such a simple and such a powerful completion, and sometimes it feels like it fucking reads my mind. And it's called hippie expand. Yeah, this is what it is. Yeah, try to expand text before point using multiple methods. Yeah, and then it just has like a bunch of functions that you can actually extend. I don't extend it myself, and I won't be surprised if its value try complete. So it tries file names, abbreviations, I don't know what these diabrefs, this is like shortcuts that you can add. This kind of like templates or something. Lisp symbol, and yeah. What else? Oh yeah, horizontal splits, of course. Like, this is fucking crucial. As far as I remember, Focus doesn't have it. This is like super crucial that I'm missing from Emacs. That's a comment, great. What else there was? I actually like Focus Search more than I like the one in Emacs, so that's that wouldn't be an issue. I use that grep. I think the UI is pretty cool, but I also have like quite some customizations to make it work for me. And I think Focus Search is actually kind of better. It's also reasonably fast, so search is not an issue. I mean, go to definition. I know Obi-Wanus wanted to experiment with LSP, you know, kind of like built in, but it's not a big deal, right? And I can implement a regular like regex space dump jump, right? So for example, here you see it just jumped to current buffer, and it used it's not intelligent, it's not using LSP, it just uses symbol completion, because so Emacs has a thing called iMenu, and right, it supports structs and functions, right? So I can call structs, and you see it knows that it has buffer and string builder. And again, if I call iMenu and functions, it will show me what functions are declared in the buffer. And this is what it uses. It's just like regex based auto completion or go to definition. So I would do something like this. Yeah, with Jai it's very easy, I agree. So I would need something like this implemented. And I mean, maybe that's it. Well, you know, I use Emacs for other like file formats as well. Like I use Emacs for pretty much anything, because I write TypeScript, I write Python, and those actually in those languages I actually rely on LSP, on language servers, because yeah, it's kind of hard to write TypeScript without language servers because it's fucking Java. Yeah. It's pretty much the same reason why you write C# in Rider, right? It's just because the language itself is so mouthful and verbose and requires so much like type masturbation that you just have to use tooling. Yeah, why don't you use Focus for C# then? I mean, need a debugger, yeah, that's fair enough. Emacs actually has a debugger support, and sometimes I would use it as a simple GDB UI when I'm like just too lazy to set up VS Code project for projects I don't have it already. But it's kind of pretty shitty. So yeah, you know, these features you can add to Focus for sure. You're close to check. 10x still like very C++ centric though, right? I don't think it has C# support out of the box. So unless you work with Unreal, I thought Tabletop Simulator is in Unity, but I don't know for sure. So yeah, I don't know if you can get it working. Like with custom hacks, yeah, probably. Yeah, probably, maybe. I know. I know some people who use 10x, they like work with Unreal Engine very heavily, and they just like swear by it. Yeah. It's like, oh my god, it's so fucking fast for Unreal. And I guess his main audience is kind of Unreal programmers, right? He like just... Yeah. He just kind of went like hardcore on optimizing 10x for like huge code bases and Unreal Engine specifically. So yeah, I guess I've enumerated features I'm missing from Emacs to switch to focus, and I can see them being reasonably added, at least in order for me switch to focus for Jai, right? Like, at least for Jai, I could be using focus probably. If I had like modal editing. Like, if I had modal editing, I could probably switch even without indentation. I don't know. But it also means that if I want modal editing in focus, I would have to be the one to add it, right? And it probably can't be just like straight up beam emulation. It would probably have to be some like configurable mode support. I don't know. Yeah. Like once Jai out, yeah, it'll... I remember somebody was posting Vim emulation for their focus fork. I remember that being the case, so somebody already actually might have it, but you know, it's as usual, it's one thing to have it in your own fork and another thing to have it like generically supported in the editor. It's kind of two different levels of integration. Because if you would add it to focus, you would not just straight up add Vim emulation, you would add key map supports similarly to ones Emacs has. Hey Alpha, hello, thanks for the good luck. Yeah, and key maps in Emacs are kind of very fucking powerful because you can literally implement anything you want on top of them. And which also means that they're quite complex, right? Say, I don't know. It's hard to say, and you know, Focus is kind of lightweight editor that's kind of aims to be VS Code like, and so maybe it's just, you know, maybe at the end of the day I'm just not a target audience. Who knows? Because, you know, Emacs, it is lightweight by modern standards, but at heart is a big, huge fucking ass IDE. It's only small because it was written in a time where 8 megabytes was a lot. So it's kind of small for the same reason why we will have a year of Linux desktop soon. Because everything else became fucking bloated. Expand. The year of people hating distros for not allowing statically linked binaries. I actually think, Sushi, that the tide is changing. I see more and more people like being in favor of it. Because every time I complain about glibc and dynamic linking on Twitter, you know, I get more and more likes. With each time I'm complaining about it. So I'm kind of thinking that it's kind of slowly coming around. And you know, with big companies who start supporting Linux, for example, Embergen Linux, there was like a blog post. Was it like Django FX blog? Oh, Linux binary compatibility. There you go. Where's the fucking link? There you go. Yeah. Look at this. This is actually a very good blog, and I agree with pretty much everything. You read it? Yeah, because I mean it was like a big deal, right? It made rounds on pretty much everywhere, and Ginger Bill posted it in his social like media. And this is a very good blog. It summarizes the issue very well. If somebody haven't read it, highly recommend. And the solution that they propose is to statically link as much as you can. That's the solution, right? Fixing it. Yeah, I don't know. Nice Python code. But yeah, this is a very good article. That's what I'm also trying to do. I'm kind of statically linking against a bunch of stuff, and what I can't link against, I try to load dynamically at runtime. Yeah. But yeah, I hope, and I think I feel that the tide is slowly kind of coming around for this. But anyway, I don't think, like after reading this, I don't think I will be able to use the same base memory for string builder and then for the resulting string, if I'll be honest. Get buffer data. So where's the data? Yeah, I know. So what I was thinking about, so I'm kind of writing a custom logger where, so the goal of this is so that the thread that uses this logger does not have to allocate strings on its own. And so I have like a data inside of the buffer that, and I was thinking that can I provide this data as a basis for both like chunks of the strings and the resulting string. And I was thinking, can I use the same like base memory address for the string builder and for resulting string when the builder calls builder to string? Like, will it collapse on top of each other? When you know how it works, it iterates over buffers and like kind of allocates into the address. And I just wonder if it like mem copies onto itself and like fucking dies in hellfire. Will that happen, or am I fine to do that? Because I don't want to like over allocate for the string builder and then for the resulting string. And I don't want to use temp allocator as logger uses by default. Like I have it here as a crutch for now, but I don't want to use temp allocator for it because this gets called from like C calls, and I don't want to initialize temp there. Like ideally I don't, because then I want to reset it and it's like a fucking very hot path, so I just want to avoid it. I might still, but I want to see if I can not deal with it. Just write the string directly. Yeah, but I need to format it, right? I need to format it. Hey, bye bye, Sushi. Thanks for hanging out. See you next time. So if I can format string without using string builder, yeah, that's why I'm reading it. That's why I'm reading how string builder works. Yeah, that's why we're here. So I can maybe use it myself. Another thing I was thinking about, so this is the append. It gets called from print to builder. And append uses buffers. Yeah, there are, but ideally I don't want to call them manually, you know? Like ideally I would just give some memory to something and it would just give me back the string and the length. Or maybe length first and then the string. Yes, I'm lazy. Another thing I was thinking about is don't bother with strings and use like an log enum or something, or not log enum, log union. And my logs, instead of be just, you know, free form strings that you call, instead you have to be like type safe about it, and you just log structs, and then these structs will get turned into string by the log consumer that can use whatever it wants, like string builders, temp allocators, you have it. So this is an alternative. This is an alternative kind of solution. Just use log unions, because I have very limited amount of types of logging. Yeah, it's rigid, but it's very powerful, and it's also very lightweight. So I have this homemade clustered ring buffer where this data is subdivided by clusters, where I use like a cluster per thread, right? And for now, when I'm sub-allocating just freeform strings, I end up wasting some of the bytes at the end of the cluster boundary, because if the string can't fit into the boundary, I have to start from the beginning, hence the ring part, right? So this is the illustration. This is the data, and each thread kind of writes into its own chunk from this data, and it kind of wraps on its own. And by wraps, I mean it just literally starts from zero instead of actually wrapping. Yeah. So, and with strings, it's not very cool because somebody has to format the string. Basically, somebody has to format the string. I was also thinking that maybe I can just store format string into this how do you say it, into this buffer, and then also store the args there. But then you don't really store the args though, right? You just store pointers, because these are any's. So the thread still ends up like owning the actual memory, and I don't want that. So what I want is so what I want is when you call something with log, so the thread that logs, it doesn't have to allocate anything. Well, apart from potentially string literals, right? Like allocating string literals on is whatever, right? It doesn't really cost, it barely costs anything, because they are in the binary. So like who fucking cares? Yeah, and I can do this with any's because they are indirected, which means the thread will still kind of own them. If they're on a stack, it's whatever, but then if you have to like heap allocate something just for logging, I want to avoid that. And so for that I must actually learn how print works to assess if I can do it easily enough with just strings, or I might want to switch to like rigid logging system with log union for regular logs and for errors. And so I guess this is where I probably will end it, and I will just read this code off stream. Because just me reading the code of Jai library is not probably that interesting. And it's also kind of late, it's 2 AM for me. So today wasn't really productive. I guess I've learned a lot about ring buffers today, about some implementation details, and I've sort of implemented initialization of my buffer, and then also this suballocation routine without an actual suballocation. Just like calculating right pointers and boundary and then wrapping it around, which, yeah, I agree it's not that much. So yeah. So I guess I'll just maybe find someone to rate. It's kind of hard to work on this shit when you know, at nights, when you a bit sleep deprived every time, but as I said, this is the only time I can do it. So it is what it is. And it's also like 2 hours like per evening. Anyone streaming software game dev who I maybe follow? Maybe Kuju is doing it again? No, not really. I don't see anything interesting. I could take recommendations. Oh, L:Q streaming. That's actually pretty cool. We can raid L:. And he's doing some, as usually, some crazy unhinged shit, which I like. So yeah, thanks everyone for watching. If you're on YouTube, you might join. You can join You can join Twitch for the raid if you want. I'm gonna raid L:. He usually does some like Emacs, Rust, C, some weird like crazy system stuff, or researching some weird stuff. So it's always pretty like entertaining to watch. I'm gonna fuck off. Hopefully I can stream tomorrow. At some point I will have to take a break. It will be like a week from now during weekends because I'm gonna be out of town, but hopefully before that I can do like 2 hours a day consistently. We'll see though, we'll see. Yeah, again, thanks everyone for watching. Have a good night, and I will see you around. Bye-bye.
I mean, it's supposed to be the case that everything that is going